Hi there, geometry students. This is Mrs. Hefty here. We're in section 4.4.4.5 and we're in part 2 of those two sections. And during chapter 4, focusing on triangles, and we've talked about congruent triangles. And today we're going to talk about proving triangles congruent. Now in our last video lesson, we talked about the postulates for proving triangles congruent. Those are called, I call them shortcuts. S was one, side, angle, side was another, angle, angle, side, and then angle, side, angle were the triangle congruent postulates. Now I need to talk about another postulate, so I'm asking you to turn to the next page of your notes, and I'll find it, what it looks like. It looks like this. You have the proof given, BD, perpendicular to AC. I don't have room on the bottom of my slide here, but you have room at the bottom of your paper. So I'm going to turn to the next slide and I'm going to ask you to write this information down at the bottom of that page because you have some room. Corresponding parts of congruent triangles are congruent. If I have triangles congruent, then the parts of the triangle are congruent. So we're going to have a postulate called C, P, C, T, C. Corresponding parts of congruent triangles are congruent. So what I'm talking about here is if you have two triangles congruent, like I have triangle ABC congruent to XYZ, then I can talk about the parts of the triangle being congruent. I'm not going to draw out my triangles, but I should know if my two triangles are congruent, then angle A would be congruent to angle X. And I should know then that XZ is going to be congruent to AC. And we've talked about that before, but we haven't talked about that postulate. So once I have triangles congruent, then the parts of the triangle are congruent by C, P, C, T, C. All right, let's turn back to that first proof on the previous page. All right, I'm given angle A congruent to angle C. So in my picture, I'm going to mark A congruent to C. And then I'm given angle ADB is congruent to CDB. And then I'm asked to prove that the two triangles are congruent. Now in the previous lesson, if I had said, hey, is the triangle on the left congruent to the triangle on the right? You probably would be saying yes, and you would be marking the shared line. So we're doing the same thing that we did in the previous lesson, we just need to write the information down. You know that in line number 1, step number 1, when you do a proof, is the given. So we need to write down our given, angle A, congruent to angle C, angle ADB, congruent to angle CDB, and that's given. You also know that at the end of a proof, you always have your proof, so you should have that written down there too. Triangle ABD congruent to triangle CBD. Now, if I had given you these two triangles in the last lesson, what additional thing would you have marked so that you could say the triangles are congruent? You would mark this shared side. So you mark it. Now you need to write that down right here. This line is called BD in the triangle on the left. And in the triangle on the right, that line is called BD as well. And I'm going to put a congruent symbol because to show triangles are congruent, I need to have 3 congruent parts. Okay, what did I just write there? Right there. Yeah, BD congruent to BD. What's your reason for that? That is the reflexive property. Now, how come those two triangles are congruent? In that third step, I need to use one of my triangle postulates. Do you see you have an angle, and a side? So why are my two triangles congruent? By angle, side. One thing that some students have problems with here is that they forget to write something down. They mark BD in the picture and then they forget to write it down. So keep that in mind if you're looking and going, I'm missing something. Maybe you forgot to write it down. Let's take a look at our second proof. All right, I'm going to dig right in. I'm going to write my givens in my number 1, and then I'm going to write my prove down at the bottom, and then let's talk about it. So I got angle 3 congruent to angle 4, DC congruent to BA, and that's given. Now I also should mark that in the picture. So 3 is congruent to 4, DC is congruent to BA. And then I'm going to go down to the bottom. Angle 1 is congruent to angle 6. Now, the proofs that we're doing today are all triangle congruency proofs. This one is not ending in triangle congruency. It's ending in parts being congruent. So I need to have my triangles congruent first, so that then I can have my parts be congruent. So I'm going to use that postulate we just talked about, C, P, C, T, C. So first I want to have my triangles congruent. So in step number 3, I need to have triangle congruent to triangle, so that in step number 4, I can talk about the parts being congruent. All right, so what additional piece needs to be marked so that I have the top triangle congruent to the bottom triangle? I would need to mark my shared side again, and once again, in the top triangle, that is called AC, and in the bottom triangle, that shared line is also called AC, and it is a congruent symbol. AC congruent to AC, and that is reflexive. Now, why are those two triangles congruent? Oh, I need to write them down. Triangle ADC. Okay, now I started with A, and that does not have an angle marking. So in the blue triangle, I need to start with C. And then I went up to here to this side, so I need to go down to this side B, and then I need to go up to A. All right, now why are my two triangles congruent? My two triangles are congruent by side, angle, side. If my triangles are congruent, then my parts are congruent. So that's C, P, C, T, C. Corresponding parts of congruent triangles are congruent. All right, let's move on to our next one. I have AM parallel to CR, so I'm going to put arrows on there. I have B is the midpoint of AR, and then I want to show my two triangles are congruent. All right, so first thing we need to do is we need to write down our givens. AM parallel, that's the parallel symbol, you can use that. CR, and B is midpoint of AR, and that's given. And then I'm going to come down here to number 4, and I'm going to write triangle ABM congruent to triangle RBC. Okay, so I want to show the two triangles are congruent. Let's go back and read our givens again. When AM and CR are parallel, then you can look for a transversal. By the way, this one is going to actually have two different ways to do it. So I'm going to draw a line here. There's two ways to write this proof, two different proofs. So there's more than one way to do it. All right, so if I have those lines parallel, then A and R are going to be congruent because those are alternate interior angles, and we learned that back in chapter 2. So I'm going to write that down. Angle A is congruent to angle R. Now that's alternate interior angles, and we should really be writing alternate interior angles, and that's a theorem. It's a theorem because that works when the lines are parallel. And we talked about that, and yes, I did let you write alternate interior angles down without theorem, but that is a theorem, so we should be writing that word in there. And that is because if the lines are parallel, then the angles are going to be equal, only when lines are parallel. So now I also need to write down, this has 5 steps. It has 5 steps. I'm looking here, I'm saying, whoa, wait a minute here now. This is 4, and then let's add a 5 here. My apologies. Let me move this down to 5, and you maybe need to do some erasing. I must not have gotten 5 on my slide. So let's fix this 2. Let's make this 4. Let's make this 5. All right, so I'm looking now, and I need 3 things marked congruent. I've got 1 thing marked congruent. I'm reading my given, and I'm reading B is the midpoint of AR. So here's B, and it's the midpoint of AR. So you would have marked these 2 equal then. So I'm going to write AB congruent to BR. Now somebody might be saying, hey, I wanted to write that in the number 2 spot. You could have done that. Those things could have been rearranged. Now this is smack dab in the middle, and I made these 2 pieces equal. This is midpoint theorem because of the congruent sign. Midpoint means equals. The theorem says, hey, you can also write it with a congruent symbol, and here's my congruent symbol. I would take, if you write definition of midpoint, I will take that. I'm not going to mark that wrong. All right, so I've got 2 things marked congruent. Some people are saying, I've noticed this right here and this right here. Those are vertical angles. And so I'm going to write that down. Angle ABM is congruent to angle CBM. And those are vertical angles. The definition of vertical angles says vertical angles are equal. The theorem says that they are congruent. So theorems are a proof is what they are. They're taking it 1 step farther. So this has a congruent symbol. So the theorem says congruent. So I need to use my vertical angles. Congruent is fine with me if you want to write that down, or if you want to write vertical angle theorem, that's fine with me as well. All right, now when I look at my triangles, I have 3 things marked. Why are my triangles congruent? My triangles are congruent by angle, side, angle. Now, I was talking about there being another way to do this proof. Some people back here, when I made the lines be parallel, and I used this as my transversal, AR as my transversal, some people maybe were saying, hey, I want to use CM. And you could have used CM as well. And so you could have had 2 things written here in the number 2 spot. You could have also had M congruent to angle C. Then those 2 would have been marked. You would not have needed the vertical angles at that point. So these would not have been marked. And so then you wouldn't have needed this step here. So then you could have done it in 4. Your reason would be different then. Your reason would be different because you'd have angle, angle, side. Last thing is that all of these steps right here could have been rearranged. They could have been in a different order, and that would have been fine. A couple of things again. We want to write alternate interior angle theorem, midpoint